we'll start with K-Nearest Neighbours. So in this classification technique, the unlabeled examples are assigned the class of similar labeled examples. Similar labeled examples or neighbors are identified by measuring the Euclidean distance between the points. So Euclidean distance between 2 points x1, y1 and x2, y2 is given by square root of x1 minus x2 square plus y1 minus y2 square. This is the same as the formula for the length of a straight line connecting 2 points, which you would have studied in your school days. The same distance measure is used here. So for an unclassified data, K nearest neighbors are identified, and the majority class of the neighbors is assigned to the unlabeled example. This image should make it more clear. Here the yellow points belong to class A and blue points belong to class B. The point denoted as star is the unclassified data. So now we would need to classify if this unclassified data belongs to class A or class B. So what we do is we take K nearest neighbors to this point. So suppose K is equal to 3. We take the 3 nearest points and we see that 2 of the points are blue and 1 of the point is yellow. Since blue is the majority among these 3, we classify the unclassified point as belonging to class B. Suppose we take K equal to 6. We take the 6 points nearest to this unclassified point. So this has 4 yellow and 2 blue. Hence we classify this as class A. Now, what determines this choice of K? How do we choose K? Okay, the choice of how many neighbors to use for classification will determine how well the model generalizes to future data. Now, there are two extremes. You choose a very high value of K. If your K is very large, almost as much as the number of observations in the data, the model will always predict the majority class. If the value of K is very small, the prediction will be very sensitive to outliers and noisy data. So your best value of K is somewhere between these two extremes. A thumb rule to choose K. Take K such that K is equal to square root of the number of observations. A scree plot may also be used to identify the optimal value of K. These are the pros and cons of KNN. It's quite a simple and effective method. It makes no assumptions about the data, unlike some other algorithms which require the data to satisfy certain conditions. On the con side, this is the only method probably which does not produce any model. Categorical and missing data require additional processing, unlike other algorithms that can handle missing data and categorical data. We'll move on to the next classification technique. So we'll have one common hands-on video for all the classification techniques. Since the model building and evaluation, all those are going to be common for all techniques. So we'll just look at the theory part of various classification techniques now.